Anybody can start using a spreadsheet to do more and more complex math, but artificial intelligence requires a team effort and a robust process to be successful. So here's a high-level checklist to run through when you're working on AI projects. First, get to know your data tools. There are many options, and you cannot learn them all. Don't try. Grab 2 or 3 and go deep. Remember the old adage about having T-shaped knowledge? You should know a fair amount about lots of things and then go deep on one. Well, that's the T-shape. Well, I want you to go deep on a couple. Then assemble the team. You know a couple of tools and you know a couple of methods really well, but that's not enough. Bring in 6 or 8 people together who know a lot about different techniques and technologies, and you can create a genius team. Next, split your data into 2 groups, one to train and one to compare the results. For example, train a model on the first 9 months of the year's data, run a projection, and compare the results to the last 3 months of the year's data to see how well it tracks. Or test your guess on half of your customers to see what impact the algorithm has on sales. Think of it like a clinical trial in medicine. Some get the blue pill, some do not. And mess around with your models. Tweak them. This is the exploration part of data science. Look for outliers and patterns, then compare what you found in this part of the data to the other part of your data. Try stuff. It's really hard to guess what will work best, which is why prepackaged solutions are far and few between. Tinker, iterate, innovate, take it out for spin. Then tune your hyperparameters. Hyperparameters are the values that govern the training process itself, the decisions you made about the models before you started. How many attributes or features do you want the machine to consider? How many layers in your neural network do you want to put in? How many nodes in each layer? Cassie Koskarov, head of decision intelligence at Google, puts it this way. Hyperparameter is to algorithm what temperature dial is to toaster. Don't worry too much about the dial the first time you try toasting bread, but once you're sure the toaster is definitely for you, do invest some time in fiddling with that dial. Once the model works well enough in the lab, it's time to test it in real life with real data. Test, tweak, test, tweak, test. Finally, you have to find a way to technically scale the model to work with real-life quantities of data that are changing in real time. Once you have that productized, you'll face a lifetime of monitoring and maintaining the model to accommodate changes in seasons, political climate, the price of beans, the vagaries in the Earth's axis precession, or whatever it is you want the computer to look at. It's good to have an overview of the whole process in mind before you jump in. That way you'll understand your role in the project and can keep an eye on the big picture while you perform specific tasks. Just don't assume you can do it all alone.